You want to test the claim that the average weight of female polar bears is different from 384 pounds. You ask 25 female polar bears their weight and record the results. Don't try this at home. If alpha, your significance level, is 0.1, find the positive critical value to 3 decimal places. So let's start with finding the claim. Always a good place to start. In symbols, we're going to use the verbiage different from 384. So the average weight is different from 384. That means our claim is that the mean does not equal 384. The opposite then of not equals is equals. So mean equals 384. So the one that has our equals, that's always going to correspond to the null hypothesis. And in general, we change the null hypothesis to equals. In this case, the opposite was already equals. But whatever that symbol is that has an equal sign, it's going to become an equal for our null hypothesis. For the alternative hypothesis, we just take the symbol that doesn't have an equal sign. No changing. All right, so we've got our null and alternative hypothesis. The alternative hypothesis tells us what direction of test this is. Because it's not equals, that means it's a two-tail test. So how we deal with that depends on whether we are looking up the critical value on our t-distribution table, or if we're using a spreadsheet. So suppose, first of all, we're going to find the critical values on our t-distribution table. I'll do the spreadsheet in a second. And one thing to note is that because it's a two-tail, we're going to have 2 critical values. One of them will be positive, one of them will be negative. They'll be the same value, just opposites of each other. So what I can do is look this up on a table, keeping in mind that my degrees of freedom is going to be n minus 1. In my case, n, the sample size, is 25, so my degrees of freedom will be 24. My alpha significance level is 0.1, and it's a two-tail test. So coming over to the t-distribution table, I'm going to look in the area in two tails because that is, because we were dealing with a two-tail test. My significance level was 0.1, so I'm in this 4th column here. And I had a degrees of freedom of 24. So that means my critical value will be 1.711. Now I just said that there is going to be 2 critical values. What we found was the positive one, but because it's a two-tail test, you also have the negative one. So 1.711 and negative 1.711 are our 2 critical values. Notice this particular question asks us to just find the positive one, and so we have done that. Now, let me go over to a spreadsheet and show you how to calculate the critical value for a two-tail test there. If I use the the t-in function and plug in 0.1 with 24 degrees of freedom, this doesn't get me the right critical value. I got 1.318 here, but I should be getting something about 1.711. What I need to keep in mind is that this is a two-tail test, and so the first thing I have to do is divide this by 2, or I can just say divide by 2. And all of a sudden, now it gives me the correct critical value. Keep in mind, this is giving me the negative critical value. Since it wants the positive, I just will have to change it to positive 1.711 when I round it.